Hello everyone, I want to explain question number 8 from exercise 5.1. The question is, if matrix A is given to us, then we have to prove product of A transpose and A inverse is cos 2 alpha minus sin 2 alpha, sin 2 alpha and cos 2 alpha. So this result we have to prove. Now for it, first I wrote here the given matrix and I assume this as equation 1. And because we have to find out the A transpose and A inverse product, so first I calculated the A transpose. To calculate the A transpose, what you have to do is this first row of matrix A just write as first column and second row just write down as second column. That is our A transpose. So A transpose we got. Now we have to get the A inverse, and for A inverse the formula I will show you the formula of A inverse. The formula of A inverse is adjoint of A upon determinant of A. So we have to first calculate the adjoint of A. So for it we need the cofactors of matrix A. So for adjoint A, to find out the adjoint A, we need the cofactors of matrix A. So first I wrote the matrix A which is given in the question. The cofactors. So for cofactors for all the places we have to calculate. So I started first by F11. F11 means first row, first column. So for this place. So for this place when we cos it, we are remain with this one element. So this one will come here. This minus 1 power 1 plus 1 always used to come with the cofactors. So when we will solve this, we will get here plus 1. Now we will find out the cofactor for A F12. F12 means first row, second column. So this is the place. Since the position is 1, 2, that's a minus 1 power 1 plus 2. It always used to come as a coefficient. Now F12. So where we are? We are at this place. So for this place when we cos this row, column and this row, we are remain with minus 10 alpha. So I wrote here minus 10 alpha here. When we solve this will give us 10 alpha. In the same way F21, 21 means second row, first column. So this is the second row and this is first column. So when we cross the second row and first column, we will get, we are remain with only the element as 10 alpha. That's why 10 alpha I wrote here. When we process it, we will get minus 10 alpha. Similarly, we obtained F22 also. So these four are the cofactors. Now to find out the adjoint of matrix A, these cofactors, this is F11, this one is F12 and this one is F21 and this one is F22. All these cofactors just write down at proper places, and then after writing the cofactors we have to do its transpose. Transpose is very necessary. So when to do the transpose, what we have to do is the first row convert to the first column and then second row convert to the second column. So we got the adjoint of A matrix. Now to find out the A inverse, we need the determinant of A also. So to calculate the determinant, you already know, we have to cos it. So this is our matrix A. So in matrix A, first this cross, 1 into 1 is 1. Then second cross is this one. So 10 alpha minus 10 alpha is minus 10 alpha. But in the formula, we have to write down minus in between them. That will give us plus 10 square alpha. So that is determinant A. Now to find out the A inverse, we will put the values, that is A adjoint of A upon determinant of A. So these equations, that is this equation 3 gives us the adjoint of A and equation 4 gives us the determinant of A. So this matrix I wrote here, and adjoint determinant A we have to divide it. So this came in the form of division. Don't send this scalar quantity to inside. Leave it as it is. So these two things we obtained from equation 3 and 4. So I wrote here from equation 3 and 4. And moreover, just assume A inverse also as equation 5 because we need it further. Now in the question they want the product of A transpose and A inverse. So A transpose, this is our A transpose which we already calculated in our equation second. I'll show you what's the equation second. This is our equation second, where we already calculated the A transpose. So A transpose, from here I substituted the value here. So this is our A transpose and this one is our A inverse. Now students, see, this is also a matrix and this is also a matrix. So this fraction is write down in front and multiply both the matrix. A multiplication of matrix, you already knew it, what to do. That is like this: first row multiplied by first column, that you have to enter here, and then again first row multiplied by the second column, that you have to enter here. So we started first row multiplied by first column. So 1 multiplied by 1 is 1. The minus 10 alpha multiplied by plus 10 alpha will give us minus 10 square alpha. So this is the product of first row and first column. So I hope it's clear to you. Now in the same way, first row multiplied by the second column. So what is here? 1. So 1 multiplied by minus 10 alpha, that is minus 10 alpha, and minus 10 alpha multiplied by 1 is minus 10 alpha. So we obtain like this. So in the product, this is the A11 place. A11 means first row, first column. This is your first row, second column element. So how we obtained it? First row multiplied by first column, and then first row multiplied by the second column. The corresponding elements you have to multiply 1 by 1, then 10 alpha by 10 alpha, like this. Now same way, this is our second row. So the second row entries you will get from the second row of the first matrix. So second row multiplied by the first column. So 10 alpha multiplied by 1 is 10 alpha. Then 1 multiplied by 10 alpha is 10 alpha. The second row multiplied by the second column. So 10 alpha multiplied by minus 10 alpha is minus 10 square alpha. Then 1 multiplied by 1 is 1. I hope for matrix product you already knew it. So first you must know the product of two matrices. Understand that, then only you will get it. Now after this you just multiply them, open the, send this fraction inside, so it will come in the denominator of all. Here we will get as it is, and this is both are in minus, so they will get add, and here also both are of positive, so it's going to be 2 10 alpha, and we will adjust it, and after adjusting it, when we observe it carefully, they are in the formula of cos 2 theta, that is I first show you the formula. Cos 2 theta is 1 minus cos square theta upon 1 plus cos square theta. Oh, I just wrote it wrong. It's actually 1 minus 10 square alpha. The formula of cos 2 theta is 1 minus 10 square theta upon 1 plus 10 square theta, and sin 2 theta formula is 2 tan theta upon 1 plus 10 square theta. So when we observe our product, it is also in the form of sine, that is 1 minus 10 square theta upon 1 plus 10 square theta is cos 2 theta. So here it will come as cos 2 alpha, and this is our sin 2 theta's formula. So see here, 2 tan theta upon 1 plus 10 square theta is sin 2 theta. That's why we will get here sin 2 alpha. Same way we wrote these also. So I hope this question is so like this question completed, and I hope you got this question. For this for doing this question, you must know the product of two matrices. So first understand it, then you will easily can understand it. And further, if you have any problem, you can write in comments so that I will clear out your doubts. Thank you.